Hello, and I'd like to talk to you about oceanic continental convergence. This is when we've got oceanic plates that come together with a collision with a continental plate. Let's just sort of draw the scene here. If we've got a continental plate meets the ocean, let's say there, and then we've got the continental shelf, and then with the bottom of the ocean floor. Okay, so to give some perspective here, let's put in the ocean. So this would be the inland, and then this would be a very shallow ocean, and this would be deep ocean out here. And we've got this area. It's made up of the Oceanic Lithosphere, and we've got a small layer of debris here. And then we've got the Oceanic Lithosphere, and below that would be the asthenosphere. And this Oceanic Lithosphere, is, I turned it down for a reason, because it is going to be, as it moves towards the continent at a very slow pace, but as it moves towards the continent, it's going to subside and go underneath, kind of sink down below the continental plate. So this would be the continental plate, and it actually has a lower density than does the Oceanic Lithosphere. So you can think of the heavier material sinking down below the lighter material, and as it does, we're deeper within the asthenosphere. So the asthenosphere, and this is where things we're on the order of 100 kilometers down and beyond. This is all molten material and very, very hot, as you can imagine. The deeper we go, the warmer things get. So as this subsides, things warm up, and this material starts to melt again, and then it can rise as any warm material would in its surroundings, and then start to accumulate in this area, and want to continue to rise. And if it finds a means to go up and up and up, it could find a path on its way up to the surface, and we would have the edge of the continental crust. So this would be the continental crust, and this below it would be the continental lithosphere. So this is the lithosphere, continental lithosphere. Okay, and what can happen here is, as it rises, this is almost like a barrier, and it'll start to collect. This molten material can start to collect here, and all that is as a result of this heavier material colliding or crashing together. Well, I say crashing, but in geology, crashing is extremely slow. And the material within the oceanic lithosphere warming up and starting to rise. And if it finds its way even beyond this point, it can be a feeder pipe to volcanic activity. Okay, so and that would be part of mountain forming processes, as the debris and materials get thrown out from the volcano and then spread across the land. We've got an upwelling here and the creation of this volcanic zone, and so on. So that's a general overview of the continental crust, the continental shelf, and basically a subduction zone leading to melting and an uprising of the material, and then potentially, not always of course, but potentially this could lead to volcanic activity. Okay, so where the oceanic lithosphere and the continental crust and lithosphere meet, well, think of this movement of the material along the oceanic floor. It gets sort of caught up right here, and all that sort of collects and piles up and this area is called an accretionary prism. Okay, so that's an area where basically material gathers and is collected, and along this area too, if we could draw our diagram now in 3 dimensions, let's see if I can do that now. If we had this in 3 dimensions, and so there's our edge of our ocean, and this area here would look like a bit of a depression and a lower area, and that area there would be called a trench. Okay, as a trench would be, it's a lower area, and so yeah, that would be a trench. Okay, right along as the progression of this oceanic lithosphere sort of tucks itself underneath the oceanic crust, or sorry, the continental crust, and creating what would be eventually a mountain range, an upwelled region that could have been ancient volcanic activity that has since cooled off and is not active anymore, or could still be active. So we could have this sort of mountain range formation, somewhat like the Alps, and so on. So that gives you a quick overview of a subduction zone. So this area here would be called a subduction zone. Subduction zone. And that's where 2 plates meet and converge, and the more dense material sort of tucks itself underneath the lighter material, sort of sinks down below. And as it heats up, it becomes lighter again and wants to rise up and come to the surface. Okay, so that's ocean to continental convergence as a quick summary.